Assalamu alaikum students. Today our topic is work and energy. First MCQ is work done by gravitational field force can be. So option A is 0, B is negative and option C is positive. So option D is correct. Work done by a gravitational force can be 0 if we carry a body through a closed path, and so in that case the work done is 0. We have studied that in conservative fields, when we carry the body in a closed path, then in that field the work done is 0. Like this, if we carry our body from this point to that point and then again we come to our initial point, then at that path the work done is 0. Work done by gravitational force can be negative. Against the gravitational force, then the work done will be negative. If we carry the body towards the gravitational force, then the work done will be positive. So option D is correct. Next, a force F acts on a body at an angle theta with vertical direction. Angle theta with vertical direction. If the body is displaced through D horizontally, then the work done by the agent is. So, look at the formula of work. Work is equal to F dot D, which is equal to FD cos theta. So, we know vector quantities, so we use cos theta. But whenever the angle comes with horizontal, like when the angle comes with vertical, then we will convert the cos theta into sin theta. We have studied in vectors and equilibrium chapter that when the angle comes with vertical direction, then we have to convert the cos theta into sin theta. So the answer is work done is equal to FD sin theta. Next one. A stone tied to a string is whirled in a circular path. The work done by tension force is. See, it's a stone. It's a stone and tied by a string here in the center. So, when the stone is whirled in a circular path, then the tension force, the work done by tension force will be 0. How? Look, tension is in that direction. Okay, it's tension. And the force and the body is moving. The body is moving in that direction. So the angle is 90 degree. And whenever we put F dot D cos theta, when we put theta is equal to 90 degree, then the work is 0. Okay? Here the angle is 90 degree. That's why the work done by tension force is 0. Next one. Which one of the following force is non-conservative force? So what is non-conservative force? Let's see. First, we have 2 points. First, we need to know that what is conservative force. We have 2 points, and the work done is from this point is, and this point is path 1. Like work done occur in this path, and like next work is done here on path 2. Okay, so when we come from point 1 to point 2 in this path, then in all the 3 paths the work done will be equal. When the work done in all the 3 paths is equal, then it means that they are conservative field. Conservative field. So what is conservative field? The work done on the body in between any 2 points is independent of the path followed. So it is called conservative field or conservative force. For example, spring force is conservative force, weight is conservative force, and electric force is also conservative force. But when the work done depend on the path, like the path 1 has different work, path 2 has different, and path 3, all the 3 work is different value, then they are called non-conservative field. So option D is correct. Dissipative forces are non-conservative forces. Next one. The work done in electric or gravitational field along a closed path is. Look, when a work is done along a closed path, it means that work is 0. Okay? Along a closed path, the work is always 0. Because in work we have studied that it is force and displacement. So when displacement is covered, like in a closed path, in any closed path, if the displacement is covered, then it will give 0 displacement, and in turn the work done will be 0. Okay? Next one. The power of an engine of a train moving with velocity v and constant force. So the formula of power is equal to F dot v, velocity. It is the scalar power is the scalar product of force and velocity. See, we know that power is equal to F dot V. So also we know that power is the work done in a second, work done per second. Okay, so we know that work is F dot D. Now take this term and put here V. We know that displacement divided by time is velocity, so power is equal to F dot V. Okay, so look at the 6th MCQ. The power of an engine of a train moving with velocity V under constant force is F dot V. Next one. The power 746 watt is equivalent to. Now see, 1 watt, we know that 1 Newton multiplied by 1 meter divided by second, or work done per second. It is called 1 watt. Now 1 horsepower, it is the unit of FPS system. Okay, 1 horsepower is equal to 550 lb, means pound. 550 pound multiplied 1 foot divided by 1 second is called 1 horsepower. So let's convert this horsepower into SI unit, watt. Okay, now we know that 1 pound is equal to 4.45 Newton and 1 foot is equal to 0.3028 meter. So multiply all these numbers, so we will get 746 Newton meter per second, and we know that Newton meter per second is equal to watt. So that's how 1 horsepower is equal to 746 watt. So the MCQ is power 746 watt is equivalent to 1 horsepower. Kilowatt hour is, now 1 kilowatt hour is, let's, kilo is equal to 1000 multiplied by 1 hour contain 3600 seconds. Okay, 1 hour has 3600 seconds, so multiply this quantity. 1 kilo 10 power 3 multiply, so I can write this 3600 like 36 multiplied by 10 power 2, so it will give 3600. Okay, now I can also write this like if I move the point from here to here. Okay, now it will be 3.6 multiply 10 power 3 multiply 10 power 3, so it will give 3.6 multiply 10 power 6 watt into second, and we can also write it like 3.6 megawatt into second, or 3.6 megajoule. Okay, kilowatt hour is the unit of energy. Okay, kilowatt hour is the unit of energy, so we can write it like 3.6 megajoule. 1 kilowatt hour is equal to 3.6 megajoule. The next one, a girl takes a bucket of 10 kg water on the level track with uniform velocity from the stream on her way to home 1 kilometer away from the stream. The work done by her on the track. So the work done by her will be 0, because what we know that work is equal to force into displacement, and the displacement must be in the direction of force. Okay, the angle between force and displacement must be 0 degree. So the work done, or it must be 0 degree or less than, angle must be 0 degree or less than 90 degree. Okay, 0 degree or, so here the girl, it's a girl. Okay, and she take a bucket of 10 kg. Okay, she take a bucket of 10 kg. She has applied force in that direction, okay, on a bucket, and carrying the bucket in that direction, like here, to her home. Okay, to her home, like it's her home. So the force and the displacement is 90 degree. It means that the work done will be 0 here. Okay, now the next MCQ. 1 joule is equal to 1 Newton meter, 1 kilogram meter square per second square, and 1 watt second. So option D is correct. Look at here. 1 joule, we know that work is equal to F dot D, and like work is equal to, and the unit of work is joule, and F is Newton and D is meter. So it means that 1 joule is equal to 1 Newton into meter. Now option A is correct. Look at the option B, 1 kilogram meter square per second square. We know that 1 Newton is equal to kilogram meter per second square, and meter will be like meter. Okay, is same. Now kilogram multiply the meter square per second square. So look at the option B, 1 kilogram meter square per second square. Option B is also correct. Now 1 watt second. We know that power is equal to watt divided by time, and also power is equal to energy divided by time. We know that. So in turn, power is equal to joule divided by second. Here we know that power is equal to watt. The unit of power is watt, and joule into second. If I bring this second into the multiplication side like here, then 1 joule will be equal to watt into second. Okay, so look at the option C, 1 joule is equal to 1 watt second. So the option D, all of the above are correct. The next one, the kinetic energy of a body of mass m moving with a constant velocity v with linear momentum is p. So what is the kinetic energy? Let's find it. Here we know that kinetic energy is equal to p square divided by 2m. Okay, it's a formula of kinetic energy. Okay, now how it's come? 1 over 2 mv square, we know that kinetic energy is equal to 1 over 2 mv square. Now divide and multiply m. Okay, multiply and divide m. So when I multiply it and divide, it will become m square v square divided by m. Okay, now m square and v square is equal to momentum. We know that momentum is equal to mv. Okay, momentum is equal to mv. So here is m square and v square. So momentum will be p square. Okay, and divided by 2m. So kinetic energy is equal to p square divided by 2m. The answer will be option B is correct. Okay. Next one. A shell of mass 5 kg is fired at 60 degree to the horizontal with a speed of 20 meter per second. Neglecting the air resistance, the kinetic energy of shell in joule at its highest point. So here is a concept of projectile motion, like a shell is fired and it makes angle of 60 degree. So with its initial speed is 20 meter per second. So the required is the kinetic energy at the highest point. We know that kinetic energy at the highest point is equal to, so we have to find the kinetic energy at this point. Okay, now we know that kinetic energy at highest point is equal to 1 over 2 mv square cos square theta. Okay, it's a formula of kinetic energy at highest point. Now mass is 5 kg, velocity is 20, and cos theta, cos 60 is equal to 1 over 2. So here is cos square theta. We will take square on 1 over 2. Theta is equal to 60 degree and cos 60 is equal to 1 over 2. Now look at here. I can write both like this. 20 multiply 1 over 2 and take the whole square. Okay, like this one square and this one. So I take it as a whole. Now 2 cutting here. 2 ones are 2 and 2 tens are 20. Now it will become like 10 square. So here take the square on 10. Like it will become 100. Now 2 ones are 2 and 2 50s are 100. Okay, now 5 multiply 50 is equal to 250 joules. So the answer is 250 joule. Kinetic energy at the highest point is 250 joule. Okay, let's next one. Kinetic energy of a particle moving with speed v is k. Kinetic energy of particle moving with speed v is k. If the linear momentum is decreased by 20%, the percent change in kinetic energy. Now here is the formula to find the percent change in kinetic energy. Now look at the MCQ. The linear momentum is decreased by 20%. Now for decrease, we use the formula like this. Kinetic percent change in kinetic energy is 2 change minus change square. The del means change divided by 100%. So what is the change? The change is 20%. 20% decrease. It's the change. Okay. Now put 20 in place of del. Okay. 20, so we will get like 20 20s are 400 and here like this. So subtract 4 from 40. Okay, so we will get the answer 36%. So the answer here is 36%. The percent change in kinetic energy is 36%. Now if the question was like this, that if the linear momentum is increased by 20%, if it was increased, then we use the formula for increase. Just put addition plus here. Okay, just put the sign of plus and then find. So the answer is 36%. Now 20 joule of work is done in accelerating a 4 kg mass from rest across a horizontal frictionless surface. The kinetic energy gained by the mass. So try to understand the question here. What is required? The kinetic energy gained by the mass. Here two conditions are given. First condition is that 20 joule of work is done on a horizontal surface. Horizontal surface here means that no potential energy, no work is converted into potential energy. Okay, horizontal surface means that no work is converted into potential energy. Okay, and a frictionless surface. The frictionless surface means that no work is converted into heat. Okay, no work is converted into heat. So it means that the whole work is converted into kinetic energy. Okay, whole 20 joule work is converted into kinetic energy. So the answer will be 20 joule kinetic energy. Okay, and here we use the formula of work energy principle. It states that the change in kinetic energy is equal to work. So 20 joule of work is done, which means that kinetic energy will be 20 joule. Okay, here just two conditions are there. The horizontal surface, which means that the work is not converted into any potential energy, and the frictionless, which means that no work is converted into heat. So the whole amount of work is converted into kinetic energy. Next one. A boy lifts a 10 kg mass to a height of 1 meter in 2 seconds, the work done by him. So the work done is equal to force into displacement. In case of gravitational, we use weight multiplied by height, okay? And weight is equal to mg and height h. So we know that mass is 10 kg, so and gravitational g is 9.8 and height is 1 meter. So when we multiply it, it will give 9.98 joule. Work done by him will be 98 joule. Okay, the next one. The ratio of kinetic energies of two masses m1 and m2 of same momenta will be. Now look here, the ratio of kinetic energy of m1 and ratio of kinetic energy of m2. Now we can write it like p square divided by 2m1 divided by, for kinetic energy 2, p square divided by 2m2. Okay, now here the momenta are same. Okay, the momenta of both masses are same. Let's convert the division into multiplication here, so it will come here and momentum will come down. Okay, now 2m1 plus p square divided by p square, 2m2 divided by p square. So cancel the p square here because momenta are same, so it will be cancelled, and cancel the 2. So look at here, the ratio of kinetic energies of two masses m1 and m2 will be like this. Kinetic energy of m1 divided by kinetic energy of m2, which is equal to m2 divided by m1. So it's the answer. Work energy principle states that work done is equal to change in kinetic energy and change in potential energy. So it's the statement of work energy principle that work done is equal to change in kinetic energy or change in potential energy. So both A and B are correct. Next one. The potential energy of a body of mass 100 gram at a height h is 1000 joule. The kinetic energy of the same mass at a height h by 4 in the absence of friction when dropped is. Now we have to find the kinetic energy at a height of h divided by 4, and the potential energy and the mass is given. Now let's find it. First of all, understand the statement of MCQ that here is some height. Okay, it's a height and a body is present here. That potential energy of body at a height, a body is present here at a height h and the mass is 100 kg. Okay, and the potential energy of the body is 1000 joule. Now the next is the kinetic energy of the same mass at a height. So the kinetic energy at a height of h by 4. Now it's a height. Okay, let's divide it by 4. So 1, 2, 3. So it is h1, h2, h3 and h4. And here given that find the kinetic energy h by 4. So at a height of this one. So it is h by 4 height, okay, or we can write it like 1 over 4. And this one is 3 by 4, okay. So what we have to do is we have to put the height this one, okay. In the formula we have to put the height this one, because when the potential energy is converted into kinetic energy, the body has to cover this one height, okay. The body has to cover this one height to convert the potential energy into kinetic energy when coming down, okay. So we have to put this one height in the formula. Now see here, potential energy is 1000 joule, okay. Potential energy is 1000 joule, and we know that gain in potential energy is equal to loss in potential gain in kinetic energy is equal to loss in potential energy. So the gain in kinetic energy will be here when the body is dropped from this one point to h divided by 4, this one point. So the body will cover this height, okay. The body will cover this one distance. The body will cover this one distance. So gain in kinetic energy is equal to loss in potential energy. And we know that potential energy is mgh. Now put mass is equal to 100 kg and g is 10, okay. G is 10. So height is given 3 by 4. So 3 by 4. When 4 ones are 4 and 4 25s are 100. So 3 tens are 30, and when we multiply it, so 750 joule of kinetic energy will be in that point. Okay, a body will have 750 joule kinetic energy on this point. Now look at here. You can also do this MCQs directly, like it's 1000 joule. Okay, it's 1000 joule and multiply 3 by 4 here. Okay, if you multiply 3 by 4, then the answer will be 750 joule. So the answer is 750 joule. I hope you get this. Now the absolute gravitational energy at a distance of r. At a distance of r from the center of earth is this. Okay, the absolute gravitational energy at the distance halfway from the center of earth will be, so the distance now r is half. So look at here, the absolute gravitational energy is this one when the distance r is r. Okay, now when we take this r half, we take this r as half, now it will become like this, r divided by 2. Now I can write it like, put the division sign here and r divided by 2. Now convert this division sign into multiplication, so it will become like 2 divided by r, and we know that this one term is equal to this absolute gravitational energy. So put in place of this one term u, only u. Okay, now the absolute gravitational energy at r divided by 2 is 2u. Okay, so the answer is 2u. It will be double. If we decrease the distance from the center of earth, then the gravitational potential energy will be double. A 40 joule of energy is used to take a mass of 50 kg up the ground. The height attained by the body is, okay. Now look at here that a 4000 joule of energy is used to take, like if we give a height to a body, okay, it will need 4000 joule of energy. Okay, now in MCQ that it's a height h, and if we bring a body from ground level to this height, so it will need 4000 joule of energy. Okay, and this energy will stored in the form of potential energy here. Okay, now and the body is 50 kg, so the required is the height attained by body. We have to find this one height. Okay, now look at here, potential energy is equal to mgh. 4000 joule is equal to 50 mass of the body, g is 10 gravitational acceleration, and we have to find the height. So bring the height, so bring these two terms in the division. Okay, in here in the division like this, so 0 will cancel the 0 and this one will cancel this one, so 5 8s are 14. The height will be 8 meter. So when we bring a body up to a height 8 meter, so 4000 joule of energy will be needed. When we bring a body of 50 kg to a height h, 8 meter height, then 4000 joule of energy will be needed. So the answer is 8 meter. The escape velocity from the surface of earth. We know that escape velocity is equal to 2GRE. Okay, now the next one, the escape velocity for a mass of 1 kg from the earth's surface is this one. The escape velocity of 4 kg mass from the earth's surface. So look at the formula of escape velocity. It's under root 2GRE. It means that the escape velocity do not depend on the mass of the body. Okay, it do not depend on the mass of the body. So look at this MCQ, that if we change the mass into 4 kg, then the escape velocity will remain as same. So the answer here is 11.2 km per second. Okay, the escape velocity will be same. Next one, the energy possessed by a water bucket of mass m when taken height h meter to the bottom of the well will be. Now here option C is correct. How? Let's prove this. Now look at here. We know that it's the surface of earth, okay, and the height here will be 0, okay, 0 meter. Now if we move above the surface of earth, then the height will be positive. Okay, the height will be increases, like from 0 it will become plus 1, 2, 3, 4, 5 meter, 6 meter, and so on. But if we go to the bottom of earth, it means that if we move the body below the earth's surface, then what will happen? The height will be decreases. It means that their value will come in negative. So here the option C is negative mgh. Look at the MCQ that a water bucket of mass m when taken to a height h meter to the bottom of a well means that it's a well, let's suppose, and it's the surface of earth. So here the height will be 0, but if the bucket is bring to the bottom of the well, it means that the bucket is moved below the surface of earth. Okay, here the height will be in negative, so here option C is correct, negative mgh. The next one, a 50 kg man climbed 50 steps, each one of 10 cm high in 10 seconds. The power of the man. Okay, we have to find the power of the man. Now look at here, we know that power is work done in per unit second or per unit time. So work is F multiplied by T or F dot T, okay? And we know that in case of gravitation, it is mgh divided by T. Now, the mass of man is 50 kg and the value of G is 10 meter per second. And the height is, now let's take the height. Here we have given that a man climbed 50 steps. 50 steps, okay, like this is 1, 2, 3, 4, 5, 6 and 50 steps. And each one step is 10 centimeter. Okay, each one step is 10 centimeter. It means that the total height will be 500 centimeter. Okay, the total height will be 500 centimeter. 50 steps of each one is 10 centimeter. So the total height will be 500 centimeter. Let's convert this centimeter into meter. So we know that 500 multiplied by 10 power minus 2 meter. So cancel this one with this. So we will get 5 meter answer. Okay, now put h is equal to 5 meter and we know that, let's cancel this 10 with 10. Okay, now 5 multiplied by 50, we will get 250 watt. Okay, the power of the man is 250 watt. Next one, a car engine exerts 100 Newton force, 1000 Newton force to move a car with 30 meter per second. We know that the power of engine is required here. So power is equal to F dot V. Okay, it is equal to 1000 multiplied by 30, which is equal to 3, okay, which is equal to 30,000 watt. So the answer is, the power of engine is 30,000 watt. Next one, a 1000 watt bulb operates 10 hours daily. The energy dissipated by the bulb per day. Okay, we know that power is equal to work or energy divided by time. We know that power is equal to energy divided by time. Now here the energy is required. So write it like this. Energy is equal to power multiplied by time, which is equal to, what is the power? 1000 watt. 1000 watt power multiplied by 10 hour. So 10 hour. So don't convert this hour into second because the options are given in hour. Okay. Now it will be like 1, 2, 3, 4 watt into hour. And I can also write it like 10 kilowatt hour. So the answer is 10 kilowatt hour. So you don't need to convert the hours into second. Okay, the answer is simply 10 kilowatt hours. Next one, the dimension of power are. Let's find the dimension. Here we know that power is equal to joule into second. Okay, and joule is equal to Newton into meter divided by second. So Newton is equal to kilogram, which means mass, kilogram meter per second square. Okay, Newton is equal to kilogram meter per second square. Now write here meter like L. Okay, and S into T. So the dimension is M L square and T cube. Okay, like this inverse. So the dimension is M L2 and T minus 3, means inverse 3. So this is the dimensions of power. Next one, which one of the following statements are correct for the work done by variable force? Number A, a rocket moved from the earth, work is done against the gravity. So the gravitational force is variable. Okay, force exerted on an elastic spring to a straight. So the elastic spring exert variable force also. Work done on a typewriter key to compress. So the work done when we compress the typewriter key, so the force is variable. The force exert is variable. So all of those. Next one, 1 kilowatt hour is equal to. So here kilowatt hour is equal to 3.6 megajoule, which is the unit commercial. It is the commercial unit of energy. Okay. So it was the last MCQ of work and energy. I hope you like the video, and if you like it, then share it with your friends and subscribe my channel. Allah Hafiz.